What is the sample space for tossing a fair coin 3 times? So sample space is listing all your possible outcomes. So you do like a capital S, and you just kind of list them in a row. So, for example, we could get a heads, a heads, and a heads. All right. We could also get 2 heads and a tails, and we could get it in this order. Heads, heads, tails. Heads, tails, heads. Tails, heads, heads. Okay. We could also get 1 heads and 2 tails, and the order does matter. So we could get heads, tails, tails. We could get tails, heads, tails, or tails, tails, heads. And we could also get 3 tails. Okay. So we're going to define our random variable x as the number of heads obtained. So in this first one, how many heads did we get? And in this one, how many heads did we get? And in this one, and in this one, and in this one, 1 heads, 1 heads, 1 heads, and 0. Okay. So we did these last time too, a probability distribution. So a probability distribution tells you the value you can get and its probability. So in this case, we could get 0 heads when we toss a coin 3 times. We could also get 1 heads when we toss a coin 3 times. We could also get 2 heads when we toss a coin 3 times. And we could also get 3 heads when we toss a coin 3 times. Okay, what is the probability of getting no heads when you toss a coin 3 times? One out of 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1 out of 8. All right, what's the probability of getting 1 heads when you toss a coin 3 times? 3 out of 8. All right, what's the probability of getting 2 heads when you toss a coin 3 times? 3 out of 8. And what's the probability of getting 3 heads? 1 out of 8. All right, so that would be a probability distribution. Okay, we can also make a graph out of our probability distribution. And when you guys make a graph, be sure you label the axes. And on the x-axis is the value of whatever you're talking about. This was the number of heads. I can either get a 0, a 1, a 2, or a 3. This is called a histogram, and there's no space between the bars. And on this side, you're going to do your probability. So I either get 0, 1/8, 2/8, or 3/8. And a lot of times they will ask you to describe the distribution. If they ask you to describe the distribution, what should you do? Sox is coming back, making a comeback. So what does S stand for? Shape. This would be symmetric. You can also have skewed left or skewed right. Okay, then we would say outliers. Well, this one I probably just wouldn't even address, or you could say none. All right, and C would be center. And the last S would be spread. You can talk about your range. All right. So what's the probability that we get at least 1 head in 3 tosses of the coin? So when you set up your probability, you got to do P of at least 1. At least 1 means X is greater than or equal to 1. So at least 1 means I could get 1 heads, or I could get 2, or I could get all 3 as heads. So the probability of at least 1, if you go back to your table, at least 1 means I get 1, 2, or 3. which means I'm adding 3/8 plus 3/8 plus 1/8. And I get 7/8. Okay, at least one also means 1 minus the probability of none. If I did it this way, I would have done 1 minus 1/8 and still gotten 7/8, because none, meaning no heads, which was 0, which is 1/8 of the time. Okay, what is a random variable? That's what this whole chapter is about. So what is it? A random variable takes numerical values that describe the outcomes of some chance process. Notice I did not write heads, tails. That would be categorical. I did the number of heads in 3 tosses. Okay, so it has to be numerical. And we've talked about a probability distribution before. And the probability distribution of a random variable gives its possible values and their probabilities. Could be a table, could also be a histogram. We also have discrete random variables and continuous. Have you guys heard of discrete and continuous before in your math lives? Great. So a discrete random variable x takes a fixed set of possible values with gaps between. All right. Discrete makes it possible to make a table because there are gaps in between. We will do both discrete and continuous, but today we're only doing discrete. Okay, the probability distribution of a discrete random variable x lists their values xi and their probabilities pi. All right, that's not as important, but that first sentence is very important. Okay, fixed set of possible values with gaps in between. And just like in the last chapter, the probabilities pi must satisfy 2 requirements. Every probability is a number between 0 and 1. So you can't have negatives. You can't have 1.5, right? Every probability is between 0 and 1. And the sum of the probabilities has to equal 1. And this is how we check if a probability distribution is legit. Do they add to 1? So let's just make sure we get this whole discrete or continuous thing. Amount of time it takes to run 110-meter hurdles. Do you guys think that's discrete or continuous? Okay, it is actually continuous unless you're going to round to some certain point. Like if you were going to round to the nearest second, then you could make it discrete. But maybe you finish in 51.529786 seconds, right? That decimal could be going on and on and on. And so you can't really put it in a table format, right? Because that time is continuous. How about number of hurdles cleanly jumped? That is discrete. Oops. All right, discrete. Maybe you jumped 5 cleanly. You never jump 5.5, right? Now, it's not just about fractions or not fractions. Is there gaps in between? So could you make a table on this? Yes, right? You could have 1, 2, 3, 4, 5, 6, 7 for your values. How about student's age, continuous or discrete? Well, it kind of depends, right? Are you like 17 and a halvesies? Or are you like 17 and 5 months and 2 days and 3 hours and 5 minutes, right? So for this one, it's actually continuous. Unless you were to specify, like, this would be better. Number of birthdays. Okay, that would be discrete because you've only had a certain number of birthdays. Okay. How about shoe size? Discrete. All right, you're definitely like a 9 or a 9.5. Okay, you have to pick a size, no matter how big your foot is. Even though there's half sizes, that's okay. Still discrete, you could make a table. Okay. However, foot length is continuous. Again, you could be measuring to the nearest centimeter or something. That might make it discrete. But otherwise, you could be in between on those tiny little centimeters. Same with student's height. That is also continuous, unless you say, like, I'm rounding to the nearest inch, right? Okay, so apparently when you're born, you get an APGAR score. And it tells you how healthy you are when you're born. So they have this table. They did 2 million newborn babies, and they found the percentage that got an APGAR score of 0 to 10. So define the random variable x, APGAR score of a randomly selected baby 1 minute after birth. The table below gives the probability distribution for x. So it is discrete because you get a score of 1 or 0 through 10. Show that the probability distribution is legit. So Jake, what would I do to show that it's legit? Sam, what do you think? Yeah. Add these all up and they have to equal what? 1. These do, so it's legit. Okay. Make a histogram of the probability distribution. Describe what you see. So when you make a histogram on this, what do you guys think goes on the x-axis? Value. And you would label 0 through 10. What goes on the y-axis? Probability. Okay. And you only need to go up to, this is the highest probability, a 9, most common right there. Probably only need to go up to like 0.5 on the y-axis. Okay, be sure you have no space between your bars because it's a histogram. And then you would need to do SOCS because it says describe what you see. So be sure you do SOCS. Okay, doctors decided that APGAR scores of 7 or higher indicate a healthy baby. What's the probability that a randomly selected baby is healthy? Now, don't just add up those numbers. You have to say P of 7 or higher. Julia, how would I write that with an X in there? So since it's 7 or higher, I would say greater than or equal to 7, right? And that means I would add up the probability of getting a 7, which is 0.099, plus probability of getting an 8, which is 0.319, plus probability of getting a 9, 0.437, plus the probability of getting a 10. All right, add all those up, and that's probability you got a healthy baby. So, since I didn't draw this out, okay, here's our histogram. Let's go ahead and describe what we see. So, Ian, what would you say for the shape? I agree with you. It is skewed left. All right, Annie, would you talk about outliers? Yeah, I probably would not on these. You might say 0 could be an outlier, or 1 or 2, I don't know, right? But I probably would just not talk about outliers. And then we've got our center. Will, what do you think the center is? Okay, so just a guess of 8. How could we know for sure what the center is? Well, you look back at your table, and the best thing you want to do is figure out the median. And the median is at what percentile of the data? Courtney? 5%? There you go. 50th percentile, right? Median's the 50th percentile. So I would like add this plus this. Nope, the median's not in there. We're not there yet. Then I would add this 0.007, still not there. Then I would add this, then I would add this, then I would add this, okay? You're still not at the 50th percentile until you add to this, and that puts you up to, I think it was like 0.52 as soon as you add that 0.319. That's when you're in the 50th percentile, is when you get to 8. So you did a nice job of guessing, okay, that the median is 8. So add and press enter in between every single one until you get just past the 50th. So if you're at 0.49, you're not there yet, okay? And so you would say 8 is the median. And then we would talk about spread. Cassidy C., what would you say the spread is? I would say 0 to 10. It's a very small percentage, right, who got a 0, but you could have 0 to 10. All right, and then, yeah, that sucks. By the way, you guys, be sure you do at least one of those in context. So I know we did all of that kind of just vaguely and quickly. You do need to like write sentences, and you do need to say something about it being in context, like relating it to newborns and APGAR scores, okay? Oops. All right, last one. North Carolina State University posts the grade distributions for its courses online. Students in Statistics 101 in a recent semester received 26% A's, 42% B's, 20% C's, 10% D's, and 2% F's. Choose a Statistics 101 student at random. The student's grade on a 4-point scale with an A equals 4. It is a discrete random variable X with this probability distribution. Notice they did not put A, B, C, D, F at the top because random variables have to be numerical. So they just related it like an A is a 4, and a B is a 3, and a C is a 2, and a D is a 1, and an F is a 0. Okay? Say in words what the meaning of P of X is greater than or equal to 3. And then what is this probability? So Thomas, what does that mean? X is greater than or equal to 3. Yeah, they got a B or an A, at least a B. All right, and Aaron, how would I calculate the probability they got at least a B? Exactly. Okay, so we got 68% of students who got an A or a B. There you go. Abby, let's see. Write the event the student got a grade worse than C in terms of values of the random variable X. So how would I write it like this, meaning worse than C? Good. You could do that. You could also say P of X is less than 2. Does that make sense? Less than 2 would be a 1 or a 0, or less than or equal to 1 would be a 1 or a 0. All right, and what's the probability of that event? Add those two together. So 12% of students got a D or an F in Stats 101. All right, sketch a graph of the probability distribution. Describe what you see. All right, so I'm not going to like actually do this, but you guys are on your green sheet, so make sure you know how. X goes on the bottom. You get a 0, 1, 2, 3, or 4. Probability goes here. It only had to go up to 0.4. And then you would say skewed left. Go through like all your stocks, okay? Any questions? All right.